Hey everyone, welcome to another podcast. Today we're going to be talking about number-based systems and how they work in the Wolfram language. Number-based systems are how we express every number that you can possibly think of. So the one that we're all most familiar with is the decimal system, 10, and it expresses all the numbers you can normally think of, 1 through 9, and then you start over 1, 0, you keep going and so forth. Decimal system comes in many forms. A different one is the Roman numeral system. As you can see here, an interesting graph is I've gone and made the length of every Roman numeral, right? So from 1 to 1,000, I1, II2, III, and as you can see, it's this interesting wave as they have symbols for very specific important ones like 100, 500, but then as they have to add the ones in front and behind, they get much longer. So you can compare this with the English, if you will, writing of every number. If you wrote all the numbers out 1 through 1,000, using the English characters, here's how long they would take. So it looks like, the Roman numerals are a much more effective means because, it peaks out over here at maybe 10 or 11, as opposed to some of these which go all the way up to like 25 digits for English. But it's kind of an unfair comparison, as when you write out any number above 10, really, you just do it in the numbers instead of like writing them out in English or, whatever language. So as you can see here, I've gone and done it, but it's very intuitive. You know how long 100 is. 100 is 3 characters. 1,000 is 4. It's very, ingrained. But this is a good way to talk into number-based systems of different kinds. So there's already a function in Wolfram language called base form, which you can plug in any number and then give it a number base, and it'll give you out a function here. Say 16 in Dosinal, that's 12-base system, is it would look like a 14 to you because there's 2 extra characters that you don't know. But as you can see here, I'm going to plug in a different system. I'm going to go ahead and do binary here. So this is what all computers use, just zeros and ones. And if you plot all those from 1 to 1,000, you can see very quickly, you're already looking at a 10-digit character before you even hit 600. They scale up very fast, then they kind of coast out afterwards, but your length exponentially increases. As opposed to here, you can see if I've gone and put the Dosinal system in, you don't even get to 4-digit numbers until you get to 1,738. That would look like 100 to you in the normal, character expression. But obviously, whenever you have a larger base, you're going to have fewer digits. But the interesting thing here for base 12 is that it's also, very divisible. You can do 1, 2, 3, 4, 6, all go evenly into 12. But for whatever reason, we stuck with 10 because we like our divisibles by 5s and 10s. So hopefully you guys thought this was an interesting way to, show some computational learning in the Wolfram language, and see you next time.